Name is Yeileen Ayon and my topic is Physiology on cerebral blood flow. Definition: the brain is the most demanding organ and it needs 15 and 100 gram minute of continuous blood supply.
The blood-brain barrier, such as other blood barriers, is a remarkable anatomical adaptation. Its most striking structural feature consists in endothelial cells, tightly joined by tight and cap junctions. These structures bind the cells side by side through several proteins, including connexins, claudin 5, and ZO1, thus maintaining the barrier's integrity. Pericytes cover about a third of the capillary surface, and surrounding glial cells, named astrocytes, support these capillaries with their foot processes. This capillary bed in the human brain has a total length of approximately 600 kilometers, with a surface area of about 20 square meters. It is permeable only to some molecules, such as nutrients entering them.
Normal cerebrovascular control. The brain is unique in that it is supplied by 4 major arteries that join in a coalescing manifold, the circle of Willis. The carotid arteries is supply approximated 40% of the total perfusion requires of the brain.
For waste products, hormones, and excess neurotransmitters that leave the brain. Only a small number of drugs are able to translocate it. To be able to do so, these molecules require lipophilicity, a size smaller than 500 Daltons, and evasion of mechanisms of active extrusion. What more is there to learn about it? What happens to it during disease? How can we effectively deliver drugs across it? Specialists from around the world are called to discuss these questions on February 2013 in the Meeting the Blood, Brain and Other Blood Barriers workshop. This event will be divided into 4 sessions. The structure and function of the blood-brain barrier, the blood-cerebrospinal barrier, the blood-retinal barrier, and beating the blood-brain barrier in drug development.
Metabolic control. Local cerebral blood flow is regionally heterogeneous. The varied pattern of CBF is neither random nor related to the anatomic organization of cerebral vasculature or to no difference in the innervation patterns of the cerebral vessels. Neurogenic control. The association of metabolism and flow does not provide that metabolism determines flow. The two variables may be governed by a common third factor. Carbon dioxide. It has been well established that alteration in PaCO2 results in marked vasodilatation. There is an exponential relationship between PaCO2 of CBF, reading of PaCO2 range or 25 to 60 mmHg, with a CBF change of approximately of 4% per millimeter of mercury.
Blood is supplied to the brain by 2 pairs of arteries. The anterior supply supplies blood primarily to the middle and front portions of the brain and consists of the left and right carotid arteries. The posterior supply supplies blood primarily to the brainstem and back portions of the brain, and consists of the right and left vertebral arteries, which then join together to form the single basilar artery. Rotating the brain so that we have a view from the left side, we can now more clearly see how the anterior supply, originating from the carotid arteries, distributes blood primarily to the middle and front portions of the brain. Two of the major arteries in the anterior circulation are the anterior and middle cerebral arteries. And the posterior supply, originating from the basilar artery, supplies mostly the brainstem and the rear portions of the brain. The posterior cerebral artery is a major vessel in the posterior circulation. And in a prime example of nature's wonderful design, there is a communicating artery which joins the two systems. Known as the posterior communicating artery, this vessel is part of the circle of Willis. In the event that there is sudden impairment of blood flow to the brain from either the anterior or posterior system, the communicating arteries allow
Autoregulation. Autoregulation is defined as the physiology maintains of a contained flow over a moderate range of perfusion pressure. This restricts use of the autoregulation in contrast to the broader meaning of the term.
Two of the major arteries in the anterior circulation are the anterior and middle cerebral arteries. And the posterior supply, originating from the basilar artery, supplies mostly the brainstem and the rear portions of the brain. The posterior cerebral artery is a major vessel in the posterior circulation. And in a prime example of nature's wonderful design, there is a communicating artery which joins the two systems. Known as the posterior communicating artery, this vessel is part of the circle of Willis. In the event that there is sudden impairment of blood flow to the brain from either the anterior or posterior system, the communicating arteries allow for crossover flow, which may help to prevent damage.
Flow thresholds. Electrophysiology techniques and accurate cerebral blood flow determination have refined our understanding of the relationship between neuronal function, tissue viability, and critical levels of regional cerebral blood flow.
Many of the important problems in science and technology and engineering at the moment are at the interface of different fields.
I had always felt that biomedical engineering, or the aspects of engineering linking with medicine, was a critical aspect of this university, and a unique one, a very unique one.
And
Cerebral blood flow and ischemic threshold. The unique metabolic requirements of the brain from the central basis for understanding the relationship between blood flow and ischemic tolerance.
Problems in science and technology and engineering at the moment are at the interface of different fields.
I had always felt that biomedical engineering, or the aspects of engineering linking with medicine, was a critical aspect of this university, and a unique one, a very unique one.
And
Alteration of cerebral function that occur at this compensatory system because overwhelmed in the face of increasing severe ischemia may be best understood in the context of ischemia, thresholds, and the ischemia cascade. Therapeutic manipulation of residual flow and alteration on flow threshold, the role of blood viscosity, the role of reperfusion, the role of calcium homeostasis.
Back out into the vascular system. Now this becomes a problem, of course, treating diseases of the brain, because we need to be able to deliver drugs from the vascular system into the brain. So at the moment, there are no drug therapies for a wide range of central nervous system diseases, and these include neurodegenerative diseases, such as Parkinson's disease. There's over 1 million Americans who suffer from Parkinson's disease, as well as Alzheimer's disease, for which over 5 million Americans suffer.
Well, we have, I'd say, personal reason to be concerned about that. We have a member of the family who is a person who is now in the initial stages, and of course we can see this happening, this horrible disease, and I realize that there has to be a solution.
Thank